So page 2 is all question 3, and it's talking about this relationship between two variables. One of them is the distance from the crest. So if you're out at Shasta Dam and you're looking over at the dam on the lake side, there's quite a bit of distance from how far down you're looking. That distance from the crest, and there's a certain spot on the dam that's considered its crest. The water can't go higher than that. But that distance from the crest level down to the water is measured in this first column. And as that distance from the crest gets closer and closer to zero, the miles of shoreline at Lake Shasta increases, right? It's a much larger lake the fuller it is. And in fact, if the distance from the crest is zero, there's 365 miles of shoreline. Lots of places to park the boat. So we're looking at those two variables, right? The distance from the crest and miles of shoreline. And the first thing we're asked to do is give the least squared regression line. And does this model appear to fit the data? So I want to review how to do that, right? In this chapter, this is not new material for this chapter. What's new in this chapter is we started to consider other models besides lines, but we're going to review how you find the least squared regression line with this tool that we have in the classrooms. So the first thing I'm going to do is enter my data. So I do that by pressing the stat button. All right, here, STAT, and then I go over, and then you can see I'm at calc, and no, actually I need to stay at stat. I need to hit stat, and then I go to edit. So I need to edit my data first. Getting ahead of myself. So stats, edit. It's occasionally a good idea sometimes if things look messed up to just go down to stats and then go down to set up the editor. So I'm actually going to do that right now. Another thing that's a kind of a good idea to do is if other classes have come in and they have things messed up, you might want to clear the list. So you can clear all the, oops, actually it wants a specific list, so we won't run that command. So let's go ahead and get in and edit our data. So once we're here and we're ready to edit our data, we're going to enter these values in list 1, right? So we'll start with the 0 there. So I'm going to enter a 0, and then I've got 62, and then I'm going to 127, and you don't need to watch this. So we do have the 62, 127, 132, 152, 162, and then 197. Now we go over and we're going to enter the Y values, which are the miles of shoreline. We're going to enter these in list number 2, and I'll pause the video to do that. So I just entered the last value, 147 for miles of shoreline. So now we're ready, because the data's in here, we're ready to go ahead and find our least squared regression line. One of the things that it also is asking for is first to find the correlation coefficient, this value R. And in order to find that, remember, diagnostics needs to be turned on. By default, diagnostics is not on your calculator. So if I want to activate diagnostics, I need to go to the catalog. So that's on the same button as 0. So I'm going to hit the blue second. Let me quit this menu first. So I'm going to hit second and then go to catalog. And then I'm going to go, it's alphabetical, so I'm going all the way down until I get to the D's. A, B, C, D. And I'm looking for diagnostics on. So you can see my cursor's right at diagnostics on. I press enter and enter again, and it says diagnostics on, done. So now that that's on, I will get the correlation coefficient as well. So let's get the least squared regression line. We're going to hit stats, go over to calculate. If we're doing a linear model, we're going to hit choice number 4, linear regression. That'll give us our least squared regression line. I press enter and enter. So there's an equation here that's modeling this data, and let's write down what it is. You can see it's in the form y equals ax plus b, and they're giving me both a and b. So if I was to write this down, I would say it would be y equals. Now, a is negative 1.1. I'm going to just round to the nearest tenth. So negative 1.1x, not 11x, negative 1.1x. And then I have a y-intercept that occurs at 363.6, so plus 363.6. So that's the least squared regression line. And it also asks us there to figure out what is the correlation coefficient. So my R value is displayed on the screen, and you can see it's negative. R is negative 0.997, and I'm rounding that. Actually, if I was going to round that to 3 decimal places, it'd have to be negative 0.998. So correlation coefficients, if you remember, range between two numbers, right? They have to be less than 1, but they have to be greater than -1. So they're somewhere in between there. At the extremes, right, when it's -1 or +1, remember what this means. It means that if you're looking at this graph of this data, right, all of the data points would be perfectly on some perfect linear model, right, when you're at -1. The slope would be, negative, it's going downward. Over here, if R is +1 on the other extreme, your data would have a positive slope. I don't know what the y-intercept would be, but the important thing is that all the data points would be pretty much exactly on the line. So, well, actually they would be on the line with a correlation coefficient of 1. So that's what this is. You can see we've got a correlation coefficient of negative 0.998. So it's a pretty strong coefficient there, very close to all the data points clustering around that line. That doesn't mean that a linear model is necessarily the best fit. One of the things we always like to look at is the residual plot and see if we should be considering some other model. But for this problem, we're not asked to consider that. Part B, or C rather, says, is the correlation coefficient positive or negative? What does this tell you about the relationship between distance from the crest and miles of shoreline? So I wrote this so you didn't have to watch me writing it. R is negative. As the distance from the crest increases, right, as those first numbers get bigger, the miles of shoreline decreases. So whenever you have a correlation coefficient that is negative like that, you're going to see as one of the variables is going up, the other one will go down. If the correlation coefficient was positive, as x's increase, y's would increase also, but that's not what we see here. The next question says, predict how many miles of shoreline Lake Shasta would have if that's a typo, right? If the water level was 250 feet from the crest. So again, if you look at the model that we built, right, our x values are distance from the crest and y is the miles of shoreline. So I could use this equation to answer that. And what I will do is, instead of I'll plug in a value of 250 for x, right? That's the distance from the crest. So if I plug 250 in for x, right, if x is 250, let's take a look at that. I would get about 1.1 times 250, and then I'm going to add to that 363.6, and it says that it would be about 638.6 miles of shoreline. So that's about 638.6 miles of shoreline. And then the last thing it just asks us to do is to plot the data roughly and draw a good approximation of the least square regression line. If you have this on your calculator screen, you can display it. I'm not going to review that here because I think you should also just be able to plot the points and then look at the slope and y-intercept and draw the equation of the line of best fit from its equation, sketch it. So let me go ahead and plot these. So this is a pretty big pin, but somewhere about here is a point. I've got one. The next point was at 62, so here's 50, 100, so 62, and we're looking at right around 295, so just slightly below 300. There's a point at 127, and about it here, one about here, maybe here, here, and then down here. So that's pretty crude, but if you were then to go ahead and let me grab a line tool, and I will just kind of draw the line of best fit. Oh geez, did not mean for that line to be this I could change those pen properties to a smaller line. That helped. So, we're looking at kind of a crude sketch here, but this is kind of what you would see on your calculator screen, and I was just kind of reading those from the points. So something like this is adequate. We definitely see the points are clustering pretty close to our model, and we can kind of see that there's some residuals here, positive residuals, some negative residuals, but that's pretty much it for this question.